So we can discuss the NEET problems. Some good problems we can discuss which are more detailed and are being asked continuously in NEET and JEE Mains. So let me start with the very first part of the chemical kinetic, that is rate. Okay. How you measure the rate with respect to particular reactant? By taking the change in concentration and the time taken for that change, right? By dividing the change in concentration with the change in time interval. With that, you can get rate, average rate, okay, between two time intervals. So let me give a question. This is the graphical question, but very easy. The NCERT also talks about the graphical question. This is the concentration of the reactant R in mole per liter. Okay, this is the graph, and this is the time, and it is 0.05 moles, 0.04 moles, 0.03 moles per liter, 0.02 moles per liter, 0. So it is decreasing, right? It is decreasing because it is a reactant. It is decreasing as the time is increasing, right? The time is taken in minutes, and you have 0.03 concentration mole per liter at 5 minutes. Okay, and you have 0. In between you have 0.015. I am writing it here. I hope all of you can see. This lower value is 0.01 and the upper value is 0.015. Got it? And this is the concentration at 15 minutes. So the concentration of the reactant is continuously decreasing, and I have given you the graph of the concentration. You have to tell me average rate of consumption or disappearance. It is one and the same thing. Of our reactant R between 5 to 15 minutes. Is it clear or not?
Yes, yes.
First of all, you have to tell me whether the question, I hope everybody agrees with that.
So, sir, can't we integrate can't we find the area between of the graph between 5 and 15? So, like, we can integrate the formula. We can do that, yeah?
No, this is just the average rate.
Oh, it's average. Okay.
So average rate, it is just like average speed. You take the total distance divided by total time. Average rate, you take the total amount of reactant which is reacted by taking the difference by time. Got it? The answer should be something into 10 to the power minus 4 mole per liter per minute. So the question is clear, I think. Jovita, it is clear or not? Final concentration minus initial concentration. Okay, this is a change in concentration because it is reactant, it is decreasing, so you need to put it minus outside to make it positive. You need to get the magnitude. T final minus T. Put a minus sign so that you get the positive answer. Otherwise, you are going to get negative answer. Rates can't be negative. They can be zero, and when they are zero, the reaction stops. Is it clear?
Yes, sir.
So, what is the answer which we are going to get? Just we need to look at it very carefully. At 0.015 mole per liter, the time is 15 minutes. Got it? So now you can figure it out very quickly and tell me the answer. Nestle
Sir,
Jovita.
our final will be having 0.015
Exactly.
minus 0.03, the whole negative, the whole minus,
Yeah.
divided by final, as in 15 minus 5 divided by 10.
The time, because it is progressing, so it is
Yeah, final
15
minus
minus.
initial.
This is 0.015 only in the numerator because you have 0.30, 0.30 and 0. Minus 0.015. So 30 minus 15 is 15 only, but you need to be careful about the decimals. Got it? By 10. Okay. In the numerator, you are having mole per liter as unit. In the denominator, you are having minutes as the unit. So it is going to be 15 into 10 to the power minus 4 Is it clear or not?
Yes,
So the answer is 15. This is the answer, right? Let me move on to the next question. So these are the most common questions, and they are very, very important because if you look at your NCRT, you will find these problems. Okay, you will find these graphical problems in your NCRT also. So very important. Okay. Next question. C is the product, so I'm writing the rate of formation of C. Okay, A, B, and C, and the overall rate of reaction. Got it? I have to calculate these four rates. And though very basic question, but very, very important to clarify all your doubts related to the rates of reactions. Is it clear or not?
Yes, sir.
Just a second. So I told you one thing. If you are measuring the rate of consumption of A, you need to take the change in A upon time, right? If you are measuring the rate of consumption of B, just need to take the concentration difference in concentration of B divided by the time interval in which the change has taken place. They are different. They can be different that depend upon their stoichiometric coefficients. Yeah, just think this is for rate of consumption of A. Yeah, this is for rate of consumption of A, correct. So Ibrahim and Jovita, how much you are getting? What values are you getting? So, so, so you are going to calculate it very quickly, right? Rate of consumption of A, rate of consumption of B, same thing you are going to, okay. But immediately in the reaction, you are not given with A or B, you are given with C. Moles of C were found to increase. These are the moles, not the concentration also. But you can get the concentration by dividing it with the volume. Is it clear? So tell me, what about the, so now you are having rate of change of concentration by the time interval. Change in concentration is the change in moles, the moles of C. Okay, delta N by delta T, and moles can be converted into concentration by dividing it by volume, right? Ibrahim, are you getting something?
Yes, sir. Yes.
These are moles. How you can get the concentration, Jovita? If you divide the moles by volume, volume is how much? 2 liters, right? This is the change. And in how much time? 20 seconds. Got it? Is it
Yes, sir.
clear or not? So how much value are you getting for dc by dt? 8 by 4 is 2 into 10 to the power minus 5 mole per liter per second. Got it? Now you can have different values for A and B because their coefficients are different. To connect them, I told you, and to make them equal to the rate of the reaction, you need to divide each individual rates by their stoichiometric coefficients. So minus 1 by 3 or 1 by 3 of minus delta A by delta T equal to 1 by 5 of minus delta V by delta T because they are reactant. I put a negative sign and that is equal to 1 by 2 delta C by delta T. I have not put a minus sign. This is the rate of the reaction. Delta C by delta T is 2 into 10 to the power minus 5. This is the rate of change in concentration of C. When it is not the rate of the reaction, it becomes the rate of the reaction when you divide it by its stoichiometric coefficient. Stoichiometric coefficient was 2. Got it? So this I hope is clear. And rate of reaction is half of delta C by delta T, that is 10 to the power minus 5 mole per liter per second into, this is the rate of the reaction, and rate of disappearance or consumption of A, that is minus delta A by delta T. Got it? That is equal to 3 times, and we cross multiply it. This value is this. Okay. What minus dA by dt, right? And rate of disappearance of B minus delta B by delta T. Jovita, is it clear?
Yes, sir.
Ibrahim, what answers you are getting?
What, sir?
Are you getting the answers?
Yes, sir. Yes, sir. Yes, sir. Did the sum.
So individual rates are there of any reactant or product by taking the change in concentration and time. That individual rates can be made equal to the rate of reaction. When you divide, then it becomes the rate of the divide by stoichiometric coefficient, then it becomes the rate of the reaction. Got it? Clear? So very simple. And the very important question also. Let me move to the next question. Okay. These rates are basically the rate of change of concentrations, okay, of reactant or product when they are divided by their stoichiometric coefficient. And you have one rate, you can get all rest of the rates. Now we will move on to the question related to order of a chemical reaction. Rate law, rate constant, and order of a chemical reaction. Got it? So rate law, rate constant, and order of a chemical reaction. Let me write the equation. Suppose this is the chemical equation. And you are provided with the concentration of the reactants at different time intervals. Concentration at different time interval and the rates, initial rates. So experiment 1, experiment 2, 3 and 4. You have concentration of BrO3 minus, got it? You have concentration of Br minus. These are different reactions. So when you start every reaction with a new set of concentration, you get different rates. So these are the initial rates. Okay, these are the different set of concentration and the different initial rates are given. Okay, now you have to tell me what is the rate law equation. The concentration, what is the rate law equation? Okay. The reaction is first order with respect to BrO3 minus. What is the order with respect to Br minus and H plus? Are you getting my point or not? If the reaction is first order with respect to bromate and BrO3 minus, what is the order with respect to Br minus, H plus? And you have to write the overall order of the reaction. Getting my point or not? But is the question clear to everybody? Jesslyn, Ibrahim,
Yes.
right? Rate of that is correct. This is clear. This question. This is the method to determine the rate law equation. So what you do, as I told you just now also in the previous class, that you take different set of concentrations and you run the same reaction. In two experiments, you keep some of the concentration same as you change some of the concentration. When you divide them, okay, when you divide them, you can figure out how the rate is changing with respect to that particular reactant. Is it clear or not? So you need to be very selective in dividing the equations so that whatever the same terms are there that get cancelled and you are left with only some particular concentration terms. But if you have lot of practice, you don't have to write it numerically. You can do it orally also. So how to do it orally? But in the board examination, you have to do it by the formal method which I told. You write the general expression. By taking order with respect to each reactant as X, Y, and Z. And you put these values, four set of values. You have four equations. You divide them one by one, but selectively divide them. Without dividing also numerically you can find out. So can you tell me what is the order with respect to H plus for just by looking? Jovita, Ibrahim, Jasleen. Can you tell me what is the order with respect to H plus and how I determined without writing anything? Are you getting my question? Ibrahim, tell me what is the order with respect to H plus? Jasleen, Jovita, tell me. How can I do it orally? Because in board examination you have to write each and everything. Then only you will get the, you have to write all the steps. Otherwise you will not get the marks. But in as far as NEET examination concerned, you don't have to write all the things. Quickly you have to calculate. Otherwise you will not have the sufficient time for the remaining questions. So look here. When you divide these two equations, this is same, this is same, and this is the concentration of H plus is, it is what? It is increased 2 times. Got it? And this is 13.4 into 10 to the power minus 5. The initial rate, why I change it to 10 to the power minus 5 so that I can compare. So this is 3 and this is 12. This is 4 times. Okay. So if I double the concentration of H plus, how the rate is getting affected, rate is becoming 4 times. Okay. So it means Z is 2. Jyovita, are you getting my point or not?
Yes, sir.
Okay. If it is first order reaction or a first order with respect to reactant, if you double the concentration, the rate will also get doubled. Justly, if you have second order with respect to a reaction, if you double the concentration, the rate will become 4 times. And Ibrahim, if you have third order with respect to a particular reactant, if you double the concentration, the rate will become 2 to the power 3 times. Third order. Order is the power. Okay.
Oh,
So
yes,
the
sir. Yes, sir.
rate will become 8 times. Okay. So orally I found out Z equal to 2. X is 1 already given in the question. And now I need to find out the value of Y. So how can I get the value of Y? So select the data. Select these two equations. Okay. So you have rate equal to 1.1, 1.01 into 10 to the power minus 4. Got it? In this equation number 3, you have a rate constant BRO3, that is 0.15 whole to the power 1. X is 1, that is already given in the question. I have already given you. BR minus is 0.5. Y. H plus I have already calculated 0.3. The power of H plus is 2. The next set of data, which is, this is for the third equation, this is for the fourth equation, this is right. Now divide the two equations. Okay. So this will get cancelled. This will get cancelled. Right. This is 2 times. So 2 to the power Y. And this is 1 by 2 square. And you have, this is upon dividing, this is 1 by 2. So 4 by 2 is 2. And Y is equal to 1. X is 1. Y is 1. Z is 2. So the reactant is first order with respect to BrO3 minus, first order with respect to Br minus, second order with respect to the H plus. The overall order is fourth order reaction. This is the fourth order reaction. Have you understood it or not? Tell me quickly, all of you. Jovita, have you understood how to do it? Ibrahim. Actually, this is
Yes.
bit longer problem, but not difficult. Okay, this you can expect in your examination. Okay, but don't write this whole data because you will not have, neither you will have time nor you will have space to do all the detailed calculation. Just apply the shortcut method, just which without dividing the equations, I calculated the order of h plus. Same thing you can do, right? Once you have the order, you can get all the rest of the things. Now we will move to the integrated rate law. As I told you, if you have integrated rate law, you can predict concentration at different time interval. You can also predict when the reaction is going to get completed. That is the time for completion, 100% completion. And you can also predict the time for 50% completion, which is the half-life. You can also predict how the concentration is changing throughout the progress of the reaction. Okay. So if I consider zero order reaction, the concentration at any time will be equal to initial concentration minus Kt. K is the rate constant. Got it? So which of the following graph correctly represent the concentration of a zero order reaction with the progress of reaction? Concentration of a zero order reaction with time. Which graph correctly represent the constant change of concentration of a reactant during the progress of a zero order reaction? I have written how the concentration changes. Ibrahim, Jasleen, tell me quickly. And this question is very easy. There is something which can help you to shortlist some of the option and reject some of the option directly. I hope you are getting my point.
Yes, sir. Yes, sir. It has to be a decreasing slope, yeah, because
Yeah,
yeah, it has to be
concentration.
decreasing slope. So it's
Yeah,
C.
it is.
It's
It
C.
is here. You don't have to get into the detail in the option. So every time you don't have to get into the solving of each and every option. No. Sometimes it is very easy because the reaction is progressing. The concentration is decreasing. Okay, this is on the y-axis, right? This time is the x-axis. The slope is minus k, right? And this is the intercept c. This is the y equal to mx plus c. Is it clear? So the concentration is decreasing. This cannot be the graph because concentration can't increase. This cannot be the graph. Concentration can't remain constant with time. This also cannot be the graph. Okay, concentration can't increase with time, it will decrease. So in this case, and it is a linear decrease, which is a straight line. Okay. Sometimes the decrease is like this. It is in the first order reaction, right? Is it clear? So what is the graph for? Rate of the reaction. How can you compare the rate of the reaction with time for a zero order reaction? And how will it look like? Ibrahim, Jasleen, Yobita, tell me. For a zero order reaction, speed of the reaction as the time progresses, how the speed of the reaction changes. Zero order reaction. Jasleen, Ibrahim, Yobita, tell me quickly. Zero order means what? Rate is,
Rate is not related with the concentration.
yeah, concentration to the power zero. Means no effect of concentration is there and the rate is constant. Rate is fixed. Okay, doesn't change. So for a zero order reaction, rate, that is the speed of zero order reaction versus time, is constant. And once the reaction is completed, it will become zero. It will touch that x-axis, means it stops. Okay. But as long as the reaction progresses, the rate remains fixed. Like that. Half-life is the time for 50% completion. And 50% completion is depends upon the initial amount. So how the half-life will change with respect to initial amount. So if you are going to take more initial amount, more will be the time taken to complete that consumption for the consumption of that half of that amount. More time will be there because you are taking more initial amount. Okay. So half-life is directly proportional to A, and it will be like this. If you double the concentration, the time required to convert 50%, consume 50% of the reaction will also get doubled. It is a linear graph. More the amount you take of the reactant, more will be the half-life. Is it clear or not? Any doubts on this? This
No.
is what this is. As per this equation, you can calculate everything. You can calculate the half-life. Half-life, you need to put this as A naught by 2. Okay, because it is the time required for 50% completion. Clear? And this is going to be A naught by K. So this, I hope, is clear to everyone. Integrated rate law. And let's discuss it on the next one with the first order reaction. First order we are going to do it in the next class, and we can, because first order is very wide and lot of questions are there. So I need to cover the first order reaction in your CBSE class, and then I will be covering it in your NEET class. Okay, a lot of questions, and these are the graphical questions which always you will see in all sorts of examinations. So let me end the class, right? Just go through your NCERT. Okay. Bye bye everyone. Take care. Good night.